Hello class again, and welcome to this particular video. And in here we're going to be exploring point and slope of a line equation, and in here we're going to focus mainly on how the graph actually influences the behavior of a linear equation when given points or slopes. And on our previous video we looked at slopes, different types of slopes. We recognize that we have positive slope, we have zero slopes, we have negative slope, and we have an undefined slope as shown in that particular nice picture I found on the internet. So in here, what is the bell work for today? The bell work here is to be able to use points to determine the slope and the equation of a line, and most importantly here is to investigate points that are actually collinear. That is the keyword that you need to take away from this particular video. So in here we're going to look at a specific example which involves a little bit of a summary on what we did on our previous lessons. In here we're going to determine the equation of a line, which in this case we notice is represented as y equals mx plus b. So the big question here is, if given the slope of a particular line, which in this case is 2/3, and this particular line passes through this particular point, which we notice to be when x is 0, y is actually -8. So the solution here is we want to put our mind around determining, one, what is the m, and b, what is the b. So in here, first of all, we need to look at the knowns given in that particular question. And the known shows me that the slope here, which is represented as m, is 2/3. So I'm going to write that down. And then the next one is that I notice that I'm given a point that passes in here, the line that passes through that particular point. So in this case, I recognize that it is when x is 0, y is -8. Therefore, this should be a bell on the head telling you that, hey, this is the y-intercept point. So therefore, b is already given in this question. Lucky us, that's pretty awesome. So in here it is -8, and once we do that, we're going to perform our use, which means that I'm going to state my y equals mx plus b. Once I know my m, in this case, is given to be 2/3, and my b is -8, I put that into the general linear equation, and this would give me my final answer, which is equal here to y is equal to 2/3x minus 8. So this is a simpler version in here. But now when we get into something a little bit more of a challenge, which tells us here that we should determine the equation of a line that has the same slope, don't forget that, as a specific line which is expressed as, I would say, almost a standard form, which is in this case 3x minus 5y equals to 10, and the same y-intercept as this other line, which is represented as 2y is equal to 6x, that's supposed to be x not y, so sorry, plus 8. So once we look at the visual, this visual tells us that for the particular first line, we notice that the blue line, which is represented as 3x minus 5y is equal to 10. And once we have that, we notice that sketching it, we actually have that line represented as that blue line on that particular graph. And if you look at the other line, on the graph, we notice that it is represented as this particular line in red. So what do we want in here? So what we want in this case is that we want to find the slope for the first line, which is blue. And once we know the slope, which is represented at that particular arrow, I need my rise and my run, and combining those will give me my m. And for the second line, I need to extract the y-intercept, which is in this case shown as this, which is where the line touches the y-axis, which is represented as b. So in this case, once I know those two key information, I can create a new line equation that is a combination of the first graph's slope and the second graph's y-intercept. So therefore, the new line equation will be represented as this, and the new graph will be just pretty much translating my first graph, which is the blue line, by a specific unit to the new B position on the second Y graph. So that is it in here. And now once we have that at the back of our mind, we're going to apply this mental thinking into mathematics and solve for this particular problem. So the solution here is that since I know that we need to determine the slope for that particular first line, that means that that slope of the first line is equal to my new line's slope. So in here, was in this case, I rearrange the equation, by which means I'm going to solve in such a way it looks like y equals mx plus b. I've already moved my positive 3x over to the right side. It becomes negative 3x. So once I have that, the next one is to divide both sides by negative 5, so that I'll be able to solve for y, which means in this case is equal to y equals to negative 3x over negative 5 plus 10 over negative 5. So in here I have to evaluate the signs on the x coefficient side. What I see is negative 3 over negative 5. In this case it is positive because negative cancels out, and my 10 divided by negative 5 becomes negative 2. Don't forget that there is a positive sign, so I have to evaluate our positive and negatives, and that gives me my negative. So the big takeaway message here is that that particular coefficient of x represents my m for that particular line, which in this case it is m to be equal to 3 over 5 for that particular first line, because I need the slope for that line. Now the second one here is that I need to find the y-intercept for the second line, because that y-intercept is the same as the new line's y-intercept. So to solve in here, we're going to rearrange this equation to look like y equals mx plus b. Now we know that y is isolated on the left side, but it has a coefficient. I can just divide both sides by that coefficient, which in this case is 2. So once I divide everywhere by 2, what I have is 6 over 2x plus 8 over 2. So therefore, once I reduce, I will have my equation to be this: y is equal to 3x plus 4. Therefore, I'm not going to be focusing on the 3. I'm going to be focusing on the positive 4, because positive 4 is represented as b, and b is actually the y-intercept. So therefore, once I've extracted my m from the first equation and my b from the second equation, that means that my new equation, we're going to put that in the general formula, which is y equals mx plus b. Since I know that my m is 3 over 5 and b is equal to positive 4, that means therefore that my new equation line will be equal to y equals 3 over 5x plus 4. So that is it in here for evaluating and thinking about how to actually combine equations together to create a new equation. In here we're asked to pick our slope from one equation, and on another equation we have to pick our y-intercept. So being able to have that broad understanding of this particular exercise gives you an in-depth critical thinking, knowledge and application of those skills that you've actually extracted or actually performed throughout this particular lesson. So in here we're going to be looking at when you have something that is collinear, how does that play out? In here we're asked to determine whether the points are collinear. So speaking of the big word collinear, this actually comes in here when you have a particular graph and we have specific points. In this case we have point A, we have point B, we have point C, and we want to see whether all these points actually are laying on a specific equation line, which means that if all these points actually, or more than one point, they all match up on a specific line, This means here that they are actually collinear, which means here that to determine what or whether those points actually lie on the graph, what I need to do is to look at first the point A and to point B. So if I have the line between point A and point B, if I find the slope of that particular line between A and B, and I check that from B to C the line slope is actually determined to be equal to the AB line slope, this means here that both lines are actually on the same line, which means that the points that are given in this question are actually collinear, which means that they are on that specific graph. So therefore in here the whole line from A to C slope means that if the number is equal to BC slope and AB slope, it means that the points ABC are actually collinear. Now if you find that the slope AB is not equal to the slope BC, that means that the points are not collinear, which means that the points they are not contained on a specific line. So let's apply this to a specific question in here, and this question will have C, D, and E points, and all these points are given right here. We have C to have the coordinates -9, 1, D to be -12, 3, and E to be 6, -9. And in here we're asked to check whether these points are actually collinear. So solution in here is that first off I need to find the slope of CD. Now CD is the line when 2 points are actually at that particular space in 2 dimensions here. So first off what I have to do is label my x1 y1 and x2 y2 for D and C, and then I'm going to solve for my slope. We know that for a graph in here, or since we're given algebraically, we need to do our y2 minus y1 over x2 minus x1. So therefore in this case my slope here, once I put those values in there, I'll find that my slope for the line CD is actually equal to -2 over 3. Now if you do now on the other side the new line, which is from D to C, and we figure out that hey, if they have the same slope, then it means that yes, the points are actually collinear. So let's check whether the line DE actually have the same slope as the line CD. So for the slope DE, we have the point for D and for E, and those coordinates will be evaluated by first labeling the x1 y1 for D and x2 y2 for E. And once we have that in here, we have our M to be equal to y2 minus y1 over x2 minus x1, and from there we actually figure out by evaluating that M gives us -2 over 3 after evaluating. So we notice here that the slope CD is actually -2 over 3, and the slope DE also gives us the slope to be -2 over 3. Therefore, since the M, which is in this case slope CD, we notice to be equal to DE, that means that the points CDE are actually collinear. So that is awesome to check out in here, and this is a visual cue to actually remember how this looks like. In here we have our x and y axis, we have our points that are aligned. This means here that we notice that the slope from D to E is actually the same as the slope from D to C, or from C to D. So therefore the question mark should be clarified that indeed the slope DE is equal to the slope CD. Therefore the points CDE are actually collinear. So this actually is a way to actually visualize what we're doing. And the final one here is another case scenario. If you're given this this particular point, and we're asked to determine whether all these points are actually collinear. So what I want you guys to do is pause this video, to challenge yourself to apply the same logic that we did, or the same steps that we did on the previous example, and see whether these points are actually collinear, which means that our line slope GH may be or not equal to HJ. So once you do that, now let's go and solve this together. So in here, for the solution, we first have to find the slope GH. Once you write your points and you label those, you actually put them in your general equation to find the algebraic slope in here. And once you put your y to y1 and x to yx1, you actually notice that for this particular line, the slope is actually 32 over 15. And once we do this now for this other line, which is HJ, and we actually determine the slope as well for this particular line, you also label your x1, y1, x2, y2, and you put those in your general equation algebraically to determine the slope. This will actually lead to this particular answer, which is 2. So once you have that, the big question is the slope GH equal to the slope HJ? No, unfortunately it is not. Therefore, since the slopes are not equal to each other, we've come to the conclusion that the points are not collinear. So that is about it for this particular exercise. In here, you're able to not only explore how points actually influence the slope and also used to determine the equation of a line, but most importantly, what does it mean when points are actually collinear? This is actually applicable if you want to do it to 3 dimensions. And if you're doing 3 dimensions, you're not going to only deal with the x and y, but you also have to deal with the x-axis as well, and see whether the point that is given in the question is actually, or points are actually coplanar. So because in here we're dealing with 2-dimension graph, which is x and y axis, we'll only call these lines to be collinear. So that's about it for this particular video. Hope you're able to understand this. There are various questions that will be assigned, and please review those. If you have any questions, don't hesitate to reach out to me either by email or schedule an appointment for a Google Meet, so that by way we can work on this together. All the same, stay smart and believe in yourselves.